Welcome to the Hannover Messe Digital Edition 2021, AWS for Industrial. What we'll be talking about is how Amazon Web Services, AWS, helps Amazon fulfillment centers actually work through industrial operations to ensure when you place an order that we make sure that promise was made to you of either 24 or 48 or a 5-day delivery is met, if not beat. What we'll talk about is how AWS does innovation to be able to create those capabilities, but also how that can be a workplace for you as you start moving forward with your business as well. I'm Douglas Bellin. I look after our business development for Industry 4.0 and smart factories globally within the AWS environment. One thing that we do with all of our customers is ask the simple question. The simple question is, if you knew the state of everything in the world and you could put reason on top of that data, what problems would you solve? Well, that's exactly what we do within AWS to help Amazon make sure that that information flow from order placement to item being picked off a shelf to ultimately being put into a box, onto a truck, and then ultimately into where it needs to be delivered has to happen. We need to understand the potential state of all of those points across that delivery system. Well, think about that in your environment as you're making something or delivering something or building capabilities from that standpoint. Well, to support this, let's first look at what you probably already know about Amazon. You probably already know about Amazon with the unbelievable scale, the unprecedented scale that we have with thousands of different distribution centers, of millions of square feet, of billions of items that are being placed on a daily access to be able to allow you to place those orders anywhere in the world and have those delivered for you. At the same time, we're looking at an incredible amount of speed of both innovation and delivery mechanisms to really stay ahead of the curve of what your customers are expecting. At the same time, you've probably seen us innovate year in and year out with new technologies, new additions, and new capabilities, both from delivery mechanisms, but insight mechanisms as well. And the reason we're able to do this is because our distinct and unique customer obsession. We look to try and understand what the customers are asking for now and what the customers will ask for in the near future, and try and beat those needs so we can always stay ahead of what those requests are. Well, to support this, as I mentioned earlier, AWS and Amazon looks at this completely data-driven capabilities. Now, yes, it's a unique, distinct opportunity that we have and a capability that we have only being 25 years old. But by being able to follow some of these ideas and capabilities, even 100-year-old companies are looking and going, how can I become data-driven? How do I look at technology and science capabilities to be disruptive and innovative throughout all of my operational aspects? How do I look at its supply chain end to end and every aspect in between it so we can look at that customer obsession? We can do continuous improvement using operational excellence capabilities and ensure that what we're doing is a sustainable format moving forward. We look at this that where design, technology, and sciences are fundamentals. They're not bolted on later, but they're integrated from the start to really ensure that what we're creating is what both customers, team members, drivers, and operators love to use in their day in and day out basis. At the same time, anything that we are doing is a way for us to improve that visibility and control across every aspect of our supply chain. So let's look at the Amazon supply chain. If we go back to 1997, we look at what Amazon started as one marketplace and two fulfillment centers. Now to us, a marketplace is something like an Amazon.com or .com.au or .com.sg, where it's basically something where we have built that website as a landing page, but it also includes all the information behind it. That information for that location, for that country, for that region, to be able to have and ensure that fulfillment center is there. Well, since 1997, we've had incredible growth and incredible capabilities moving forward, with over 150 million prime customers, over 500,000 full-time employees and contractors working in a day in, day out basis globally to ensure that we are making sure those orders are fulfilled. Looking at 17 countries with those marketplaces and growing every year. Over 300 fulfillment centers. Over 180 of those fulfillment centers are what we call robotic enabled fulfillment centers, which we'll share with you in a couple of moments. And globally, of those 180 different robotic-enabled fulfillment centers, plus our other fulfillment centers, there's over 200,000 robots working in harmony day in and day out basis. Now, all of these are connected through technology to give you that unprecedented scale that hasn't existed before, to be able to ensure those capabilities and those drivers are exactly what you're getting and delivering from that aspect. But this also means an incredible amount of complexity. Think about billions of customer orders that are happening in real time, hundreds of millions of automated ordering plans to ensure that those products are on the shelves, on those devices to be able to be picked when the order is placed. This means working with tens of millions of vendor purchase orders, looking at hundreds of millions of customer promises daily and weekly, and over hundreds of thousands of vendors that we're dealing with on a global basis to ensure everything is in place for you. Well, to support this, we looked at what a traditional supply chain flow looked like. And traditionally, what this was a lot of just-in-time ordering, just-in-time shipping capabilities, reacting to shipments, reacting when that order is placed and a fulfillment center gets the order to fulfill. But the problem was every time we looked at something reacting, it was a delay. That could be seconds or minutes, as well as many times those reactions were human touches. And every time a human touch occurs, it is both time and money that starts to get implemented and compounded as we go forward. Well, to us, a second is a long time when you're starting to look at hundreds of millions of orders that are being placed. So we want to always shrink that time frame to reaction. When you look at our supply chain, the difference is end-to-end automation capabilities. We go from forecasting what you might order to understanding where that order should be placed. How much square footage do I have available for that order to be dropped in? So when you place that order, it can actually be shipped to the customers. How much square footage do we have for each customer, for each location of what they potentially are going to be purchasing? That also automates our buying program. So when our buyers are looking at what we should be purchasing, they're looking more at an anomaly capability, not just the regular run-of-the-mill capabilities. We also look automatically of where those items are going to be put into our warehouses and how we have that fulfillment capability from there. Almost 100% of our inventory is ordered automatically. In fact, it's greater than 99% of our inventory is ordered automatically, which means that our purchasing department actually is doing value-added jobs within their roles. They're looking at those capabilities and understanding where those things are starting to maybe sell more and how can I do reallocation into where those items are starting to sell and why they're starting to sell so we can react to this and build that into the automation moving forward. Now, all of this has to be powered by machine learning. The value that we're looking at, the calculations are unbelievable when you start looking at forecasting over 400 million products daily. You can't have that many people to be able to look at this. So you have to have the capabilities to look at that from an automation standpoint. Looking at what type of inbound carrier into what locations those products need to be actually sent to. And then looking at how I can actually allocate automatically by regional band when that redistribution is occurring and is needed to occur because maybe we're starting to see something sell faster in other markets or in other areas than what we thought it would in the past. Well, to support this, we have an incredibly complex and incredibly powerful warehousing system that we call fulfillment centers. We don't call them warehousing because warehousing a lot of times means it's going to sit there. Fulfillment means we're going to fulfill those orders and get those into the customer's hands as quick as possible. Well, normally, what I would do is take you into one of our fulfillment centers and really walk through a location like this, which has thousands of associates working. We've got about 65% of this 1 million square foot building dedicated to robotics in an automated robotics location, which this is. Now, these are built to do about 1 million units in a 24-hour period. It can flex up, it can flex down, but on average, we do about 1 million units per day in each of those locations out there. Now, since I can't walk you through this, let's actually play the video to do the virtual walk as we go forward with this.
Ever wonder how Amazon gets your packages to you so quickly? It's done with a symphony of machine learning, automation, and our amazing associates. Join us as we see that in action in an Amazon fulfillment center. Welcome to an Amazon Robotics sortable fulfillment center. This FC is one of more than 50 worldwide, where robots work alongside our amazing employees. Let's go inside. At Amazon, we're customer obsessed. We're also obsessed with the safety of our employees. In April of 2020, Amazon began enhancing its temperature screening process by implementing thermal camera systems throughout multiple business lines in North America. Now that our temperature is not detected as high, we're free to continue the tour. Today, we're going to follow the path of products from where they're received, stowed, then picked, packed, and put on a truck for distribution. The inbound process starts with forecasting and ordering before anything arrives to the FC. Powered by AWS, Amazon's forecasting engine is used for over 400 million products daily. Let's go to the receiving area. As you'll see, we put a lot of energy into our logistics. It's a symphony of people, AWS, software, and other high-tech components. The result is a coordination between our great employees and the finely honed computer systems we've evolved for more than 20 years. Our employees are the heart and soul of our operation. Some are military veterans, some are active members of the community, some are employees that work here with their loved ones. They're all amazing. Trailers full of vendor and small and medium business seller items arrive at these bay doors by appointment. Employees unload the trailers and begin the process of staging items located at their receiving workstations. This FC carries millions of items of inventory, and using the service known as Amazon Aurora, we manage our inventory transactions and other relational database needs. At this station, you can see how our inbound associate receives a product and how those products are stowed in our inventory. Amazon robotic drive units are activated when an associate logs into their workstation to perform their task. Storage pods arrive facing the correct side to stow items into inventory. Every time an associate touches a product, they scan a unique barcode for that item, which we call the Amazon Standard Identification Number, or ASIN. That's stored in our inventory system, so we know what the quantity and location of that item is at any given time. To manage our inventory history, we use Amazon Neptune, a fast, reliable, fully managed graph database service from AWS. Now, you might expect that we'd organize this in a way where similar items are stowed together. For example, all electronics would be stored in the same section. However, at Amazon, we've found that it's more efficient to stow products using a randomized method. That's why you'll see a variety of items in each inventory bin. Once that process has been completed, a physical and digital match is created in our systems. So just a few seconds after an item is stowed, you can order it on Amazon.com. Looking at a station next door, we see a great example of computer vision helping with automation. When an associate scans an item, you'll see magenta lights over some of the bins in the pod. This lets the associate know not to place that item in those locations, as artificial intelligence-driven logic has determined that the bin is full, that placing an item there may negatively impact the pod's overall weight distribution, or that a visually similar item is there and may cause confusion later when an associate needs to pick the item. The associate can then place the item in any of the other bins. But computer vision doesn't stop there. It will also detect what bin the associate reached into and knows where that item is placed. As one final step, it will take a picture of the pod and use image recognition to count the number of items in the bin, making sure the count matches what is recorded in our tracking systems. When the machine learning model has low confidence, it sends images to people to classify and train more ground truth data for our machine learning model, which operates in Amazon SageMaker and Amazon SageMaker Ground Truth from AWS. This allows us to perform ongoing inventory reconciliation, avoiding the scheduled inventory counts that are often done at least once a year at other organizations. Now, what's up with those robots we see moving the pods around? There are thousands of robot drive units spread throughout each floor, helping associates fulfill customer orders daily. Amazon Robotics operate in dedicated fenced-off areas within the FC, which account for about 65% of the facility's total square footage. The drive units travel to various locations in our FC to pick up mobile shelves of product and deliver them to employees who are working at ergonomic workstations. To navigate, they read 2D barcodes on the floor, and locations are tracked in real time using our own created robotic operating software. Our Amazon Robotics team has developed more than 100 services to support operations and uses AWS extensively in the Amazon fulfillment centers. Only specially trained individuals wearing custom safety equipment are allowed to enter this area, but on our virtual tour, we're allowed to walk through this restricted area. Each sortable FC has over 1 million unique items, helping us with our goal to provide Earth's largest selection. You may be thinking, okay, robots are great, but I just ordered an item. How's it picked? To answer that, let's go to a pick station. Here we see a similar layout as our stow station. Once you hit the Buy button on Amazon.com, our systems will cue the robots to find the inventory pod with the item you ordered. Once that item has been identified, the robot will bring it to our associate. A screen at the associate station will show them a picture and quantity of the item they need to pick. The same visual bin inspection system is used as during stow, except this time, instead of lighting up bins where items should not be placed, the system lights up in a white light where that item is. The associate identifies and grabs the item, placing it in the yellow tote signified by the green light, and pushes the button, acknowledging that the item was placed there. When the system detects that the tote is full, the light flashes and the associate pushes the full tote back to a series of conveyors and replaces it with a new one that was automatically brought to their station. At this stage, associates are picking items for different customers in batches. The two types of picking processes we focus on are single item orders and multiple item orders. The single item orders contain only one item per customer order. We fill up a yellow tote full of single item orders weighing up to 25 pounds. The single item order yellow totes will then be routed to the singles pack lines for packaging. The multiple item orders contain more than one item per order. If your multiple item order of 6 items are all in this building, then it's possible that your order is being picked up by up to 6 different people picking items from 6 different robots, which all need to be brought together for your single shipment. Your items will be placed in any available yellow tote and routed to our multiple item order assembly stations. It's at that point that we will rebin your individual items into one customer order. Then, once all of your items are together, it's packing time. To help improve efficiency and also reduce environmental impact of the packaging, the size of box or envelope is automatically selected by a machine learning algorithm. Even the correct length of tape is determined by machine learning and automatically dispensed. If needed, protected packaging materials are added. A barcode is placed on the package, it's sealed up, and away we go. That barcode will be important for the next stage that we call SLAM. But what if I order 2 items and those items are in 2 different FCs? Do I get 1 box or 2? The answer is, it depends. Our first priority is to get you the item at the date and time that we promised when you placed the order. The second priority is to do that at the lowest cost possible and with the lowest environmental impact so we can continue to pass on lower prices to you. With those 2 things in mind, we use machine learning to figure out if it's optimal to ship to you from each FC in 2 different packages, or ship an item from one FC to the other, combine them there, and ship to you in a single package. You're now seeing our SLAM line in process. SLAM is an acronym which stands for Scan, Label, Apply, and Manifest. The technology here scans that barcoded sticker placed on the package in pack and immediately knows to print the correct shipping label on the package. This is the first time your name and address are placed on the package. So how do we know which carrier to use? That's also determined by machine learning. In the space of a few seconds, an algorithm is run to determine the optimal delivery carrier to get you the package on time and at the lowest cost possible. There are also quality control measures in place here. Following this, the box is weighed and the weight is checked against the item's known weight. If the weight is off, the order will be routed to a special location. From there, an associate will open the package and take the applicable action. We're now entering the final stages. After passing all of those quality control measures, the package is routed onto another series of conveyors to a location where the label is scanned. The conveyors then automatically send each package down the correct chute, where it will be packaged on a semi-trailer for shipment to another FC, or a sortation center for final delivery to you. There are approximately 17.5 miles of conveyor belts in this FC. In order to run reliably, every single day, they're monitored via AWS IoT services. AWS IoT Greengrass helps here by allowing devices to act locally on the data they generate while still taking advantage of the cloud. Events, in particular from the machinery, are sent to Lambda functions in AWS that trigger step functions. These workflows then coordinate RME operations to maintain the equipment, perform inspections, replace faulty motors and belts, and other types of activities. We even collaborate with some of our automation suppliers using AWS ML models to predict equipment failures and address issues before they arise. Thank you for visiting our Amazon Sortable Robotics Fulfillment Center. We hope you enjoyed our virtual tour.
Welcome back. Now let me dive into a couple things that you saw. A couple things that we were able to talk about and show you was one of the areas that you spent a little bit of time of was the put away location. We call it random stow. What happens is an associate, like you see right here, has a yellow tower in front of him. Over on his right-hand side in this picture, maybe left-hand side, depending on the location. He would have boxes that are coming in that he needs to get that inventory into inventory. He needs to pull those boxes out and put each individual item onto these little yellow towers to be able to have that actually now be part of inventory. If it's sitting on his shelf, it is not part of something that you can purchase yet. What he needs to do is take that item out, automatically scan it without using a scanning gun, be able to put that onto the shelf using what we call random put away. It's a lightly guided process that says you can put this anywhere on this shelf. What we want to allow them to do though is be able to put it anywhere on that shelf because that allows us to do quicker and easier retrieval when somebody buys that order. Think of in the old days, everybody had CDs. If we put all of the same CD on one shelf and suddenly everybody ordered 10 of those, it would take 10 different stations to be able to pick all 10 of those and be able to sort that, put that down to each individual order. But by being able to put random put away capabilities, what we're allowing the associate to do is put 1 or 2 CDs per location. That way, when 10 orders are placed, no longer is it waiting and stalling for each order that's placed, but now those orders can be displaced across multiple different towers and picked from that standpoint. To support these capabilities, you saw a ton of barcode scanning. There's a lot of different touch points that happen, both from inbound boxes and bins that are occurring, storage locations to understand where these are being put away, the pick bins. Each individual item and bin has a unique identifier within that. And then ultimately, as it goes out the door, each individual shipping box also has a barcode on it. That's an incredible amount of data that we need to be able to store, but that we can track and look at that low-cost routing when we're starting to look at that allocation going forward. The other thing that we see and you saw was around bin visioning system. What this is taking that location again, looking at computer vision, both assisted placement, but also assisted picking capabilities. So on that big yellow tower, what would happen is there a actual light screen comes across with that to show them which location they should be picking the item from. Now, in that little slot or in that shelf that sits there, there might be 7, 8, 9 different items in there. Yes, they still have to be able to choose that, but at the same time, what it allows them to do is focus on that one box and then on the one item that they need to pick. On the other side here, you see a gentleman working with our Amazon Robotics robots and understanding there might be an issue in this case. Maybe it is stuck or maybe it's out of battery. Doesn't happen very often, but periodically we do have to go out there and understand what's happening, understand what's going on in that field of that 65% of our million square feet that is under that robotics environment. It is pulling and picking those capabilities and bringing those yellow towers to the associates in real time, using computer vision capabilities to ensure that their stock is in stock in real time. Now, that's a complex environment. It's an incredible amount of data that starts to flow. But hopefully this has given you a couple different examples of what you're able to do, both from maybe computer vision, data access control capabilities, some ideas to be able to bring that into your environment. But again, thank you for listening and watching the video and taking our virtual tour for us. Hopefully this gave you some great insights to understand where we're at and how some of these capabilities could be brought to your market as well.